In question 8 we have electrons accelerated through 300 volts and then diffracted. In part A we're to show that the final speed is 1.0 times 10 to the 7 meters per second. Well, the electrical energy, EV, or charge Q times V, in this case the charge is the charge on the electron, becomes kinetic energy, mv squared over 2. Big V for potential difference, small v for velocity. So we can rearrange to get the velocity, which is what we want, as the square root of 2ev over m. Then we can put the numbers in. 2 times 1.60 times 10 to the minus 19 times 300 volts over the mass of 9.11 times 10 to the minus 31 kilograms. This gives a speed of 1.03 times 10 to the 7 meters per second, which is two significant figures, is 1.0 times 10 to the 7 meters per second as required. For B, we're to find the de Broglie wavelength. Well, the de Broglie wavelength is given by the Planck constant over the momentum, mv. This is 6.63 times 10 to the minus 34 for the Planck constant, divided by 9.11 times 10 to the minus 31 for the mass of the electron, times the speed we've just found of 1.03 times 10 to the 7 meters per second. This gives a wavelength of 7.1 times 10 to the minus 11 meters. For C, we're told the potential difference is now increased. We're to explain how the diffraction pattern will change. Well, if the potential difference is increased, the speed will increase. Therefore, the wavelength, the de Broglie wavelength, will go down. So the rings will become smaller.